Okay, this is our 7th part of our factoring series where we're going to put together all of the methods we've learned, and I will show you how you can confirm your answer on your graphing calculator. Remember, we have been following the factoring path where first we look for the greatest common factor, and then we looked for opportunities to do grouping, trinomial factoring, or binomial factoring according to these 3 patterns: the sum of cubes, the difference of cubes, or the difference of squares. Let's try a few. 7x squared minus 28. We look at this and right away we want to try to take out a greatest common factor. So we'll pull out the 7 and we'll be left with x squared minus 4. Once we've pulled the 7 out, we can see then that x squared is a perfect square and 4 is a perfect square. So we can continue to factor and we'll end up with 7 times x minus 2 times x plus 2. This is the fully factored equivalent of this expression, or so we hope. In order to confirm that, we will type them both in on our calculator as separate entries. 2x or 7x squared minus 28, and then down below 7 and the parentheses x minus 2, and then another set of parentheses x plus 2. If they are the same, then when I look at the graph, I should only see one thing. If you're not sure if it's exactly the same, you could look at the table. And the y1 and y2 columns should be identical. Every value matches up because they're equivalent. So I'm convinced that I have indeed factored this expression correctly. Let's try another one. Here we have 20x squared plus 16x minus 48. I see that it's trinomial and I'm eager to factor the trinomial, but before I do, let me look for a greatest common factor. Let's see, I could divide them all by 4. I can't do 8 because the 20 is not divisible by 8, and I can't do, so 4 is the highest. So I'll take a 4 out, and I'll be left with 5x squared plus 4x minus 12. Now I need to try to factor what's inside, all the while remembering that this 4 is part of the factored expression. I have to keep carrying that down. So now I'm doing trinomial factoring. I need 2 numbers that multiply to give me a times c, which in this case is negative 60, but they need to add to give me 4. I'll think about the factors of 60, and I'll say, well, 1 and 60, no. 2 and 30, no. 3 and 20, no. 4 and 15, no. 5 and 12, no. 6 and 10, yes, that's a difference of 4. I know I need a difference because I have a negative value for a times c, and I know I want the 10 to be the positive one because when I add them, they need to add up to 4. So we're going to have a 10 and a negative 6. After I find those, I split the middle term. So now I carry this 4 out in front, but I have here 5x squared plus 10x minus 6x minus 12. Now I'm grouping. From the first 2 terms, I can take out a 5x, and I'm left with x plus 2. From the second 2 terms, I could take out a negative 6 and also be left with x plus 2. I have to keep bringing this 4 down because it is a factor. Okay, I have the 4. I can pull the x plus 2 out. And then I have 5x minus 6. This is what I believe to be the completely factored version of my original expression, but let me check it. I'll go to y equals. Clear what's in there for right now. I'll put my original expression in for y1, 20x squared plus 16x minus 48. And the next one will be 4 times x plus 2 times 5x minus 6. I'm going to look at the table to see if they're identical. And they are. So I know I did it right. So you can see that what we want to do when we factor is start by trying for the greatest common factor, then try one of these, depending on how many terms there are, and keep going until you can't go any further. And then once you have your answer, enter the original expression and the final expression as two different equations, and make sure the tables line up. Hope this makes sense and that you can be an expert at factoring.